different models. If you'll see, so in the deep learning, we are having a convolutional neural network, recurrent neural network, LSTM, Guru, and so many. So these are the different models. They are having their own role in the deep learning. Okay, so we will start with the session which is based on sequence modeling, and we will see what exactly a sequence modeling is. What is the need to model the sequences, okay, and what are the tools and the particular concept by which I can model the sequence data. Fine. So these are the contents that I'm trying to cover. Sequence modeling is what that we will see. Then we will see what is the problem in the neural network which we cannot use for this. Then we will see the recurrent neural network, okay, which we use for modeling the sequences. And then there is another model which is the advanced version of RNN called as long short-term memory. Fine. So we will see what is a sequence modeling. Fine. So sequence modeling, what exactly is? It is an ability to predict what comes next in the sequence. Okay. So let's say an example. Suppose some particular series I ask you to learn. Okay, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. This is yes, and I asking you to learn it. So you are learning 1, 2, 3, 4, 5, 6 likewise. Fine. And then immediately I ask you what comes after 5. Now you have done so much practice on that, so you will simply say after 5 it is 6. So that is exactly a sequence modeling, ability to predict what comes next in the sequence, what is coming in the sequence, or you can say in such a way that what comes in the future. Okay, by processing the current data and the previous data, what comes in the future that predicted. So that exactly comes under the category of sequence modeling. Right? So in sequence modeling, what we require means we require certain data, or we require certain memory. Okay, so there is a need of sequence modeling. Yes, there is a need of sequence modeling. It is because of these two things. We are having a sequence data and we are having a sequence memory. Fine. Without sequence memory and without sequence data, you cannot do sequence modeling. So example of sequence data, the data of weather forecasting. Okay, so weather forecasting data is with respect to time. Every second the data is generated. Yes, so that is a sequence data which is over the time. Fine. Similarly, you can take another that is called as the data of exchange. So in the stock exchange, the data is keep on changing over the time. So that is a sequence data. So lots of sequence data we are having. Moreover, we are having a sequence memory, because to handle a sequence data, we require a sequence memory. We'll see in detail what exactly a sequence memory. So due to sequence data and due to sequence memory, we can able to perform sequence modeling. Right? So this is about the sequence modeling and having its own applications. So applications of sequence modeling, we will see little bit applications we will discuss in this session. So moving further, and we will see what exactly a sequence data is, because the understanding of data is more important whenever you are applying the sequence model, let's say RNN, LSTM, Guru, or some other advanced sequence models. So what is the sequence data? So before to that, I am quoting one statement: RNN neural network that are good at sequence data. Okay, this is the statement I am quoting. So in RNN, we are having a different types of RNN. Yes. So it is a neural network, is good for modeling sequence data. Okay. So this statement later on will going to prove really it is the sequence modeling or not. Fine. So let's say we are having one example. The example says that predict the direction of moving ball. Okay. So there is a some ball which is moving here and there, left, right, up, down, likewise. So what we want to predict that in which direction the ball will going to move. Okay, going to move. So now we can take an approach. The first approach says that what we can do, we can capture the still image of moving ball. Okay, we capture this moving ball. So the moment you capture a still image of moving ball, now this is going to become your data. Fine. And now in the approach one, which we are supposed to follow, what we are doing, we are capturing only one instance. Okay, only one instance. So if you will capture only one instance, and this is only the data which you have. So with this data, it is really impossible to predict what is the direction of moving ball. You cannot do it because it's just a still image. You do not have in what direction that particular ball was moving. But while taking a picture, it was moving, but when you capture picture, it is a still image. So that will not going to help you. So the first approach fails to predict the direction of this particular ball. Okay. Now toward the second approach. Second approach says that what you supposed to do, you have to record many snapshots. Okay? You record many snapshots of a ball position in succession. So what will happen in second approach? You are having lots of images, still images with respect to time. Okay, that means he sequenced it, and this sequence data definitely will going to help you to predict the direction of moving ball. So first approach here fails, but the second approach helps you because you are gathering the data over the time as in when ball is moving here and there, and then that data collectively going to help you to process the sequence data, and it will going to help you to predict ball is moving in particular direction. Okay, so this is about the sequence data. In this case, if you'll see, my sequence data is images. Okay, images are taken in succession. Images are taken in with respect to time. So this is one category of data which is in sequence. Then we want to continue with the sequence data. So you can have the sequence data which can be an audio or which can be a video, where it is a combination of audio and video both. So in audio, you can have in such a sequence where here also your audio will going to play with respect to time. Yes, so you cannot process that entire audio. Okay, so what you can do, you can break that particular audio into small chunks. Okay, and then that small chunks will going to become your sequence data. Okay, so that you can decide, okay, you can have 5 seconds of audio or 10 seconds of audio or 20 seconds. That is free. You are free to choose that particular interval, break that entire data in the form of sequences, and then that you can process. So audio sequence data can be utilized. Let's say there is some audio is playing, and we want the genre of that audio. Okay? Who is singing that particular song? So we want to identify that particular genre. So that kind of processing you can require audio data. Second one is, and the third kind of data is a text. So text is another form of sequence. Text, let's say an example of sentiment analysis. This is one of the popular area of research where people are identifying the sentiments out of the text data. So what happens in there? We are having a lot, and then that lots of data is having some meanings. So some one sentence having some meaning, then continue to that sentence, another sentence is having some another meaning, and by getting the gist of all these sentences, the sentiments are getting declared. So in a text, what we can do, we take the text either in the characters or in the sequences. It is totally depend upon how you want to process. You want to process character by character, or you want to process word by word. But most of the time we process word by word. So if you are having a large text, so what you can do, you can break the data into these sentences. Okay, and then one sentence will going to become your sequence data, which will be textual. Okay, where we cannot disturb the sequence. If you're going to disturb the sequence, your result, whatever you ask, will not be that much accurate. Fine. So this is about the sequence data which we have. So we are having an image data which can be a sequence. We are having audio data that can be a sequence. We are having a text data that can also be in the form of sequence. Now moving further, what exactly a sequence memory is, because this is very important, because without sequence memory you cannot process the sequence data. What exactly it is? Sequence memory is a mechanism that makes it easier for your brain to recognize sequence pattern. Okay, so it is something like this, a brain. So we are having a brain, and with that brain we are learning so many things. Yes, now here I have quoted one example, the alphabets A, B, C, D, the letters in English, A to Z. Okay, from the childhood it was instructed by our teachers that we have to read A, B, C, D, E, F, G, and now this pattern is there in our mind. Okay, we know that whatever the letter I'll ask you, you will immediately say it. You will immediately say it is Q. I'll ask what is after T. You will immediately say it is U, because your brain has been trained and your memory is working in that particular sequence in such a way that as and when it is asked what is next after particular letter, your brain will respond. Okay, so here it is an, so that particular brain we can keep as a model. Yes, brain will going to become model in terms of deep learning model, and that model will going to tell what comes next when a particular input is given. So now in this case, if I'll ask what comes after U, so definitely you will say it is V. Fine, but let's say another example. Now I have reversed the sequence. Okay, and this is itself a kind of a sequence. Yeah, I have reversed this. Now it is A, but it is starting with a Z and ending with A. Reverse. Now, in this case, if I'll ask you what comes after P, your brain will not going to respond immediately. Yes, because it requires a kind of a training so that you have to learn ABCD. It is Z, Y, X till A. And then over the time, you'll keep on learning this sequence. Then your brain will respond, yes, after O, there is a N. After G, there is a F. Okay? So this is exactly the sequence memory playing at this particular instance. Now, taking another example, suppose this particular A, B, C, D, X, Y, Z, let's say it start with D. Okay, it start with D. So suppose it is starting with D, so at that you will not having any problem. So after D it is a E, G, immediately your brain will respond. But when you are reaching to Z, your brain will not going to respond. Why? Because you know that after Z there is a no letter. But in this case, our series is brain. Okay, it will train the brain that after Z there is a C, then there is a, there is a B, and there is a A. In there is a C, the A, some exactly a sequence memory, which is really helping us to recognize what comes next, fine, in the respective patterns. Now moving further, what are the application? Because it is very, very important. Most of the time we are not knowing where we supposed to apply the particular model. Yes. So now in this case, I have listed certain applications you can, and these are the real application. More and more people are working on these applications towards to contribute in the community. So the first application I have taken where sequence modeling can be applied, it is a speech recognition. So this is one of the famous application. Even we are having a smartphones where we are having a Alexa kind of application, or even Google assistant is there. So in that, what uh, we are speaking something, Google, hello Google, or something like this, or you want to search something on the Google. So what exactly here, it is a speech recognition. So you are speaking, which will be in the form of this signal, and then that is converted in the equivalent language. In this case, it is a English, and accordingly that Google Assistant works or Alexa works. So in this case, what happens? Your input is audio clip, and your output is producing the text transcript. This is also you most of the NPTEL videos. You might have registered for some of the NPTEL. So for every NPTEL video nowadays, we are getting the transcript. Whatever that has been spoken, or whatever that has been delivered by the expert, that everything will be in the form of the transcript. So here, what will be input? Audio will be considered a sequence which will be played over a time, and transcript is a sequence of word. So from this, the word get generated. This is a one application. Another application is translation. So in machine translation, this is one of the difficult and popular as well, because machine translation talks about converting a sentence of one language into another language. So it can be any input language and it can be any output language. So that output language will be your targeted language. Yes. So here you can see the example. The example I have quoted over here. Here in the both the left hand side you input, in the right hand side you are having an output. So in this case, both inputs and outputs. But here it is not one mapping. Yeah, this is one of the important thing that we need to understand. Okay, now every sentence will be created with the grammar of English. That will be not like that. Fine. So, and moreover, there is another issue. See here, uh, this is the one word, but it is exactly two words. Yeah. So these two words may map to one word in English, or one word in French may have the relevance in three words in English or more than one words in English. So that is one of the complexity which lies over here, the time of conversion. And moreover, this let's say this MOI, this MOI is not directly a me, it can be something else also. Okay, so we cannot make word to word conversion from French English. If we do that, what will happen? You will not going to get meaningful sentence in English. So there is the challenge comes in picture, where grammar to be get checked when the model is getting developed at the time of conversion from French language to the what we say in English language. Okay. So now the challenge. So nowadays more people are converting the language which is English, and they want to convert in some Tamil or Telugu. So in Tamil and Telugu, more complexities are there, and moreover, the alphabets in Tamil and Telugu, they are similar. Okay, so there the grammars need to be there, and this is one of the application nowadays being utilized in Sansad Bhavan, because there are many reasons people coming to attend the meeting, and there some people do not know English, so their translation has to be there. So likewise, it is having a huge application, and widely used as per the current state. Right. Now moving further, another application I want to talk. This is one of the popular application nowadays, where you are having a sequence of frames, and here we want to find out what going on in the video. Okay, activity going on in the video. So input is a sequence of frame, and output the model predicts what activity is going on. So this is one of the important area of research, where this can be society. Let's say an example. Suppose a guy posts some video on YouTube, and in that YouTube video, some misleading informations are there, some riots are there, or some other kind of things are there. That particular sense, if that video comes in the social media, so there is a chance that there is an imbalance in the society, or there is a clashes in the community. So what we can have, we can process that video, we can identify what kind of activity is going on. If that activities are favorable, then that video will be get circulated, or that can be have other people. Now in this case, if we are having a frames and some players are running. Okay, this is a one sports where some players are running, and then the output is running. So your input is images and your output is text. Okay. So now here we want to discuss on this video activity, where in video activity you are having an images. Okay, and from the images we want the text. Now this is one of the model from one of the paper, where we are having the same objective is there, but intentionally I want to show you that in what way you can design the models. Okay, you can design the models. So already CNN you have seen in the previous class, where the objective of CNN is to extract the features. Yes, whatever the features that are there in the image, it extract those features, and it made that feature available. Okay, so that we can process further. We cannot process image, we cannot process text, we can process only with respect to numbers. Yeah, so all the features that has been extracted by the CNN, which will be in the form of numbers, and then here that numbers are mean pool, and then that entire info pass on to the some layers of LSTM, and then these LSTMs are processing, and at last they are telling, yes, output is a boy is playing a ball. So LSTM, the question is, LSTM is a long short-term memory. It is the advanced version of, okay, that I'll going to cover in the session itself once we will going to finish the RNN. So LSTM stands for long short-term memory. It is the advanced version of RNN. So moving further, so now we are the problem which is ANN. Okay, so we have finished till this point the sequence data, sequence memory, and now we want to see what exactly in ANN and what are the problems in ANN Henceforth, we have to use recurrent neural network. So now try to understand this problem. So this is exactly artificial neural network. Okay, in artificial neural network, what we are having a neurons, and that neuron get connected to all the neurons in the next layer. Similarly, so here we have taken only two layers neuron, but generally we are having more than that. For simplicity, I have taken only two layer. Okay, this is input layer and this is the output layer, where each and every neuron is connected to respective neuron in the next layer. Now here the question is this: what for dinner? We want to predict what is dinner tonight. Yes, we want to predict what is dinner tonight. Okay? So now to do that, okay, we got some information. Okay, we got this information, so that the information which, by understanding the problem, we got the information that the data, rather seeing information, we got this particular data, day of a week. On a particular day of a week, something was prepared, so that we have taken as an input. Month of a year, in a particular month of a particular year, the food was prepared out of this, and then some late night meeting was there, and at that time some food was prepared. So that kind of input we have taken here with respect to this neuron. Okay, now this information will be fed over here, this neuron will process, and now they try to predict whether it is a biryani, pulao, or dosa. Fine. So either of these three, one will be the answer as per this question. Fine. Now, but in this case, if you'll see the left hand side, okay, this, if you'll see whatever the data which we have chosen for this problem statement, it is not that much relevant. Okay, it is not that much relevant to give you the correct answer, give you the correct prediction of dinner tonight. Right? Now, I make this problem more clear. Suppose we are having one person, let's say Mr. Singh. Okay, we are having a one person, and Mr. Singh is preparing a food every night. Okay, every night he prepares a food. Moreover, he is having a habit to invite his subordinates, his neighbors, or his colleagues on every night, okay, for a dinner. So the first thing is, there is a one Mr. Singh. He prepares a food. Moreover, his the Mr. Singh prepares the food in a particular pattern. Okay, so he's having a pattern. In one night he prepare, next night he prepare pulao, and after that night he prepare dosa. So there is a pattern: biryani, pulao, and dosa. Fine. So now if we'll see this, so this pattern will definitely help you, and that will help you to come up with very simplified neural network. We don't require this much complicated neural network, and we don't require this unwanted or information which is not much relevant towards to get this result. Okay, towards result. So there is a question regarding someone is not given the exam. So you just write a mail. I'll take a action. I'll give the opportunity to give the exam. Don't. Okay, Sheikh sir, no worry for anything else. Okay, you just write a mail, and some alternative arrangement I'll do for you. Right. So to make this simplified, so now why we are doing, so we got a pattern that Mr. Singh prepares this particular, the order of food preparation is like this. So by taking that particular data in consideration, okay, what we can have, we can remove this data, and that particular data we can keep here. So now your model and your data, which will be going to come like this. So what we are considering, we are knowing that, yes, we are knowing that this is the pattern. Okay, with this particular pattern, food is getting prepared. From that only we got a data. So what data we got? Biryani yesterday. So if biryani yesterday, so what can be the dinner tonight? So the dinner tonight will be a pulao. If it is a pulao yesterday, if it is a dosa yesterday, dinner tonight will be the biryani. So now we got an data which is really relevant in this case, which we can feed to this neural network, and where we don't require more and more connection. Only simplified connection is more than sufficient to identify or to predict what is dinner tonight. So I think this is clear. So we don't require more complicated neural network. That's why we got, in this case, if we'll see processing some sequence data, okay? The data is in sequence. The sequence is biryani, pulao, and dosa. So here, what is the objective? Just we want to predict what is dinner tonight. So for that, we are considering the input something like this. Make our neural network or the model more foolproof, what we can do, what that has been predicted, that also we can feed the network. Okay, so the more and more you are feeding to the network, the more and more accurate result you will going to achieve. So now, just I told you that whatever that has been predicted, which you will supply to this neural network. So we got three more neurons where they will going to handle the information predicted biryani yesterday. That means the prediction that was done, that information also we are considering at this particular point. Moreover, whatever that has been considered previously, that we have kept as it is. So now with this information, with this data, and with this data, we can able to predict more accurately in this case is dinner tonight. Okay, so what we are trying to do, whatever that we have predicted, we are once again supplying to the network. Okay, we are making a loop kind of thing over there, so that more and more learning will be there, and the model is get saturated, matured enough, so at that time definitely it will going to give the accurate result. So due to that, your accuracy will get automatically increased. Fine. So now in this case, so we come up to this point. Now we will stop the example over here. This we will going to continue later. Before to that, we want to understand what are the representation of information, because most of the time what happens, we are not analyzing the data, or we are not understanding the data in what way it is represented or in what way it is stored. So now we want to devote some time for that as well. So now here there is a notations that we want to see. So let's say I am having a some sentence which is represented by X. Example here is Harry and Larry invented a new speed. This is my input, and this input is a sequence. Yes, this input is a sequence. This is the first, this is the second, this is the third word likewise. Now this input I want to my network, my deep neural network I want to feed. We know that neural network or any other program, they cannot understand what exactly this is. They need to get converted in the form of number, and then that need to get processed. Fine. So here we need to get the equivalence representation of this in the form of numbers. Okay, then it will be very, very easy. So what we are doing, we are representing, we are saying that xt. Okay, so xt, what it will do, it will represent each word of the sentence. So this word, and this word. So with that we get a word. H of 1 is a Harry, that is. H of 2 is and, that is this word. And H of 3 is this. And similarly H of 4 up to the last word. Now here, if this is the input and this is the analogy or this is the concept which we use, so your output will going to become 1 0 1 0. How we got this? Here we are making certain assumption. The assumption is wherever there is a name of the person, we will write 1. Wherever it is different word other than name, we are going to put 0. So with that, this is one vector which is the representation of this. And now this you can easily give to the neural network. Yes, this will get processed. So the meaning of this is this. Fine. So moving further with this, let's say, so how do represent n individual words in a sequence? So now in this case, we are talking that your data is a textual data. Okay. So if your textual data is there, you cannot feed the textual data directly to the model. We need to convert in the or in respective encoding. Fine. So the question over here is, how do we represent n individual word in a sequence? So that representation has to be very much clear. So to do this, solve this question or to answer for this question, what we have to prepare the vocabulary or dictionary. Okay, we have to prepare the vocabulary or dictionary. So, and moreover, there are two things that we need to consider while preparing vocabulary and dictionary. First point is, size of vocabulary might vary depending upon the application. The vocabulary may not be of same size, which will be same for some another application. It is totally depend on how much data you have. Okay, so with that, vocabulary size will be different. Second, make a preparation of vocabulary or dictionary. What approach we can use? You can find out most frequently occurring word. Okay, most frequently occurring word you can consider, and that you can put in your training set. So with that, you can get the required amount of text data which really required for the data to train and then to process. Fine. Moreover, some other approaches, moreover, some other what we can say assumptions you can make, like the word like who character word you can remove, character word you can remove, likewise, and accordingly you can prepare your vocabulary. So that everything will be totally depend upon a particular application for which you are developing the vocabulary or dictionary. Fine. So moving, this is an example of dictionary. One dictionary we have prepared. Just try to understand. This is an dictionary. So here, this is the first location of the dictionary. This is the second location. Likewise. So there are so many words. Now this is your dictionary. But when I want to process a particular word, let's say I want to process for Harry. So for Harry, I have to represent the, I have to have the particular representation in number. Right? Let's say an example. This Harry is at the location 50th location. Okay, it is available at 50th location 50. In that case, the representation of Harry will be from 0 to 49. Everything will 0, and location number 50 it is 1, and then from that point onwards to last it is 000. So that is the meaning of word Harry in the dictionary. Similarly, if the Potter is available at 100th location to 99, everything will be 000. In 100th location it is 1, and from that point onwards everything will be 0. So this way individual word will get uh, the representation in the dictionary, because what we do in a sequence, one word is get processed, not all the words. Yes, so that we can process that entire text and get a meaningful information out of that. Now moving towards the other concept, which is called as a vector, because in the deep learning the entire information is getting represented in the form of vectors. So that's why it is very important to understand. So what exactly a vector is? Just a list of values. That's all. List of values. Okay, we are talking values. One real life example. So now I am having some weather information at time t1. Okay, at time t1. So the temperature is high, that is 67 Fahrenheit. Then it is a wind 20 miles per second. Then there is humidity is 75%. This is the info. This is the data with respect to time t1. Likewise, we can have lots of data with time t1, t2, t3, t4. Likewise, but I cannot process this text. Yeah, I cannot process. So what I have to do? I have to convert this in the form of vector. So what I can do? Just I can identify what are that keywords and related information or related data with that keyword. So high temperature is there, low temperature, rain in inches, and humidity. Corresponding to that, we are having a value. Now we are getting a one vector over here, which we can say it is a weather vector. So where we got everything in the form of number. Okay, later on this particular data we have to normalize, because we know the neural network, all the information will lies in between 0 to 1. So the normalization will be get applied over here, and then that data will get processed further. So now see, the data was like this, but now we are having the appropriate implementation which can be handled by deep neural network. Fine. So now this is the weather vector for T1. Similarly, we can have for T2, T3, T4, and then that can be fed to the neural network. Right? So here, this is a sequence. It's complete is the data of one instance, then another instance, likewise. So now with that particular concept, there is another concept which is called as a one-hot encoding. What one-hot encoding says that whatever is important in the particular data, you represent that as a 1, and the remaining you represent as a 0. Okay, whatever that you want to process, represent that as a 1 and everything will be represented as a 0. So this already one-hot encoding with the example, this is exactly called as a one-hot encoding. So now I am having a two exercise. So now I need your responses for that. First exercise is it's Wednesday. For it, I want to write or I want to come up with week vector. I want to write a vector for Wednesday. And there is another exercise. Tonight, I think we are going to have pulao. This is related to that dinner prediction vector, dinner prediction problem. Fine. Okay, previous slide. Okay, I'll explain the previous slide. Previous slide speaks about that you are having a data and this is your input. Yes, this you have received. Yeah. So this how you can convert. Identifying high temperature, low temperature, wind speed. So this 67 whatever is there, what this indicates? This 67 is indicating the high temperature. 43 is representing the low temperature. So every row over here it signifies something. What? This all. So the last row which is this indicates humidity. Right? So we are converting this entire thing in the form of this, and now we know the significance of each and every row over here, what they indicates. Right? I think it is clear. Okay, so I got some answer 1010. So conversion means the conversion is whatever the that is Mitra sir, yeah. The conversion means like high temperature information data you have. Yes, high temperature is what 67, which is this. So whatever the way you want to arrange, any way you can arrange. At the start, you can have humidity wherever. So here, this 67 means what? This 67 means high temperature. This 0.50 means what? This represent rain. So here, what we are trying to remove this all textual information and only numeric information we are constricting. And with that, we are going to get a weather vector. This is the conversion over here. Later on, you can apply the normalization on this. You can limit the value from 0 to 1. Okay. Now you can see 0.50, 0.75. For this normalization is not required, let's say. But for 20, 43 and 67, you can do the normalization where this will 0.20. That normalization will depend on what is the minimum value and what is the maximum value. With that, all the range will be get decided. Okay, so in that way the conversion will be. Now moving further, so now answer from you that what will be the weather vector for Wednesday? Yes, there is a correct answer. The weather vector can also be from 0 0 0 1 0 0 also. This can be an answer also. 0 0 0 1 0 0. This can be also the answer. It is totally depend upon what whether you take a Sunday as a first or Monday as a first. What can be for the this tonight? I think we are going to have pulao. Anyone? So for this pulao example, we are having a three data values. First one is a biryani, second one is pulao, and third one is a dosa. So now you are having a three data values. That means, so based on that, what can be the one hot encoding? Two cannot be the answer. Okay, two cannot. One hot one one hot encoding, 0101. Likewise, you will going to have. So in the second example, yeah, the correct answer is this. Yes, the correct answer is 010. It's correct. Fine. So now you are with me. Now these are the answers. So for first week, week vector. So if you start with Monday, so 001 00, and if start with Sunday, so this one will come here. Likewise. And then for the second one, which was pulao, so biryani is first, pulao is second, and dosa is third. So wherever there is a pulao, it is one. So you will get a vector over. Now this will be very easy for the neural network to process later on. Okay. So now this is about the vector. So now we are coming back to the problem. Yes. So you are giving the correct answers. Vinod Babu has given correct answer. Sharma sir, Sharma madam has given the correct answer. So, okay, so I'm getting the answers. Fine. Thanks. Thanks for your cooperation. So now we are moving back to that same problem which we started, where we want to predict the dinner. Fine. So now this was the network which we had. Now that entire network which was like this, yes, this everything now we will going to convert in the form of vectors. The concept just now we have seen. Now we have converted over here. So this is one vector. So this is prediction yesterday vector. This is the dinner yesterday vector, and this is the prediction of today. So likewise, we got the vectors. Right? Now moving further. Now what we are trying to do over here. So in neural network, you will keep on getting new information. That new information will be get represented in this form of vector. And then what we are doing, we are making a kind of a prediction here. This is the prediction. And same prediction we are feeding here. What exactly we try to achieve? We try to achieve the better prediction or accurate prediction based on new information and based on previous prediction. So see here, we are able to get, yes, so this loop is really helpful for us towards to have the accurate prediction once we have a new information. So with this, we get the recurrent neural network. Okay. So as the recurrent neural network, recurrence means repeatedly something is getting feed to the neural network. So what is that something? The prediction, or we are submitting to the neural network itself. Okay. So we will come to RNN, but before to that, we want to continue the same example which we started, that dinner. So now here question is, if you are out for 2 weeks or so, suppose you are the person and you have visited Sing for a particular night for a dinner. Okay. So on that day you had some dinner. So either you had a pulao, biryani or dosa. Fine. Now what happens? You went out of uh, for some reason you are out of station for 2 weeks. Fine. So now here, can we predict? The question is, can we predict what is dinner tonight? Okay, I think you got my question. You are the person, you have visited the house of Mr. Singh for dinner, and after that day, you went to the some another place due to some official engagement, and after 2 weeks, you return back, and now you want to predict what is dinner tonight in the house of Mr. Singh. I think my question is clear. So can we predict? That is my question. Okay. So can we predict? So yes, it is possible to predict, though you have left out. So how that is possible? I can show with this particular slide. So this is the dinner prediction tonight. Okay. So we can unfold that entire network. Okay. We can unfold that entire network. The point you left that till today. So you keep on unfolding, keep on unrolling, keep on unrolling. So definitely here that it will going to help you to predict dinner tonight. So after doing unrolling, you directly come to the date 2 day ago dinner and then yesterday dinner, and then you will going to know, okay, today this particular will be the dinner at Mr. Singh's house. Fine. So that is the beauty, and that we will going to continue with this. With that, we're going to come to a recurrent neural network. So this is exactly the history of RNN. This way we got a RNN. So in the RNN, if you see the model, you are having a new information that will be given to the neural network. So what is the job of network? To predict the way we have seen here. This is your neural network. Okay, this is your neural network. What the job of this? It is just going to give some prediction. So network, then it is connected to this particular function. This is already discussed. This is called as the sigmoid function. The job of is limit the value in between 0 and 1. Okay. It is not tan h function. Okay, so it will going to limit the value in between -1 and 1. Then that particular will be going to become a prediction, and then same prediction will going to feed here with respect to new information. New information here, and then that will once again given to this neural network, and then there is a squashing. So this way again and again, again and again, again and again, information is going to feed with respect to new prediction, new information, prediction, new information. In that it will process. Fine. Moving further, so now we come to a particular model which is a recurrent neural network. So now here we are having this new function. This we need to understand how this works. Okay, so this is a hyperbolic tangent which is called as a tan h. The job of that function is just to squash the output. Whatever the output that is generated by neural network, it will going to squash in between -1 and minus 1 and 1. Okay, it is also called a squashing function or a gating function. There are different names. Fine. So this is, you got an introduction of recurrent neural network. So just we have seen in a recurrent neural network, what we have the latest prediction. Okay, this is the prediction available for the new data. Before to that, whatever the prediction that has been done, it is already processed. It is not there in the memory. So now with this concept, now we want to have one case study. Write a children's book. Small childrens are there, and for that we want to write a book. So generally how we teach the children, we are teaching them this is dog, likewise. So after this we are is the next word. So we are expecting that the children should say this after this is a dog, likewise. So similar kind of book we want to create here by using RNN. Okay. In the book, we are having a 3 sentences. Dick saw Jane, then there is a full stop. Jane saw Spot, then Spot saw Dick. Only 3 sentences because these children are very small. At the start, we are asking, we make them to learn some particular small. So only that's why the sentences are very small. So whenever you are having a text data, so what is the job? You have to create the dictionary. Okay, so dictionary will be get created. Dick saw Jane Spot, something like this. Okay, Jane, these are the dictionary which we have created. This dictionary is having only 5 words because we are having less sentences, and in the less sentences we are having a less word. Right. So now we want to simulate this. So what is the objective here? The children should tell, or the model which we are preparing for the children, that will going to tell, after Dick there is a saw, after saw there is a Jane, and after Jane there is a dot, something like this. And similar saw, and after saw the possibility can be a spot. So just we want to predict what will be the next word in the sentence when it starts from, let's say, Dick, Jane, or Spot. So now with this example we move further. So now this is the neural network which we have seen previously. So now as the size of dictionary is getting increased, so that many neurons are there. So total 5 neurons are required because we are having a 5 words. Okay, 5 here, 5 here, 5 here. Fine. Now new information is getting fed into the neural network. Right? So what is my new information? Dick. So Dick is only a one word in this dictionary. So I have to have only the representation of Dick. So how that can be represented? 0, 1, 0. This we already seen, which is called as a one hot encoding. So 1, 0, 0, 0, and 0. This will be fade over here. Okay. Then this, and this, it is getting processed. It will going to tell what can be the. So when it is a Dick, so that is the name of the person. Whenever there is a name of the person, if you see this example, whenever there is a name of the function, so what it's supposed to predict? Either it's supposed to predict saw, or it's supposed to predict dot. This has to be given by the neural network. Yes. Similarly, if it is a saw, so it has to predict the name of the person. And moreover, if it is a dot, that means it has to come, some new word will going to start. Same here. So we are feeding this. Right? So when it is a Dick, that is the name of the person. either of these three. What it's supposed to predict? It's supposed to predict either it is a saw or dot. Saw or dot. So from here also, from here, saw and dot. Right? So new informations are keep on coming based on this neural network. The job of neural network is just the prediction. Fine. Suppose if it is saw and dot, if saw and dot is there, so it has to predict. Okay, similar here and similar here. So this way we are having a particular neural network where this is the vector. Okay, and these vectors which will be represented, which will be in the form of neurons. Fine. The input is coming, output is produced, and this output is also getting feedback to the neural network. Okay, so with this, so that was an example where we are trying to design the children's book. With the RNN, we are having some problem. So the problem is it is making some mistakes. So what the mistake is? It can generate the sentence like this: Dick saw Dick, but it is a wrong sentence. Yes, here it another name. Either it can be a Jane or it can be a Spot. Moreover, if you'll see, this sentence is not ended over here. This is the one mistake that has been done. How it will do that we will see. Then J saw Spot, saw Dick, saw. So now here it is a ever-ending process. This sentence is not getting ended, and again these sentences are generated. Then here our sentences immediately get finished after a particular word, that is the name of the person. Spot dot Dick dot and Jane dot. These three mistakes will be done by RNN. Why? We will see the more clear. So this is the model of RNN. So what are this RNN having in the memory? This is having just previous prediction. Yes, this is the previous prediction. Previous to previous is not known to the RNN. So due to that, let's say if my input is Dick saw, and after that it has to predict something over here, but information is missing. Only this is known. Okay, only this word is known and this is missing. So due to that, it will going to take Dick as also the correct option. Similarly, here when Jane saw Spot, after that there, okay, but this information is missing. Only this is available. So due to that, this is ever ending. Okay, then here after Spot, the dot is identified. Okay, after Spot, dot is before to Spot, nothing was known to the neural network. So due to that, this sentence is generated. So what is the problem in RNN? It just know the previous prediction. Previous to previous, it is not known. So due to that, this kind of mistakes are. So to avoid this kind of mistakes, we are having the advanced version of recurrent neural network. We'll move further. Okay, so here we are once again revisiting to the RNN. So we will see the respect to the artificial neural network, which we used to say ANN. So what happens in RNN? RNN to learn mapping from X to Y. So you will going to have some X input and it will going to map with Y input. This is not RNN. This is your standard neural network. Okay, where either X or Y or both X or Y of same size. So in RNN, which is a sequence model, whatever we are inputting, that input must have some particular length. Okay, that must be same to input and with respect to output. But if you'll see, we can't use a traditional neural network as a feed-forward neural network for this sequence. So there is a problem. What happens in neural network? You are having so many hidden layers. Every hidden layer get connected. The neurons is get connected to all the neurons of the hidden layer, and likewise. It will going to become more complex. Moreover, whatever the size of input in artificial neural network, the size may not be same here, and whatever the output that will be produced may not be same here. There is a problem. Even the size of x1, size of x2, they will be not also same. So that is the one of the problem. That's why we cannot use a ANN. So what is the problem? There are primarily two problems with neural network. The first one is input and output do not have a fixed length. Okay, but that is the necessary condition in sequence processing. Moreover, some input sentence can example can be of 10 words, while other can be not equal to 10 or more than 10 as well. And that same is true for output as well. Now moving further, in a neural network, okay, neural network, what happens? The feature sharing, see here, we'll see an example. Now this is one neuron, this is another neuron. This neuron is not sharing with this neuron, but this neuron just compute the result, and this result is get forwarded to all other neurons. Sometimes if sharing is required here and here to take a kind of decision, so those kind of functionality is not available in neural network, but that is there in the recurrent neural network that we will see more in detail. So not able to share features across a different position of text if we use a standard NN. These are the two limitations. Okay, these are the two limitations. That's why we cannot use neural network for sequence data processing. Further, this is a basic architecture. You have many, if you have visited on Google or if you are interested in sequence modeling, so you have seen structure. So this is a basic model, and it is having some hidden states, that are previous hidden states, and this is the cell state, this is the input. So input is getting processed, and then we will going to get the new hidden state. And this is one of the popular diagram where this is the input, hidden state. Okay, it will perform the operation, and then that result will back once again. The some output is also produced. So output is produced, result go back to here as well. This is a loop kind of thing, again and again, again and again it is get repeated for new input, not for same input. Okay, this input is processed, so hidden state will change, the next input will come, hidden state will change, likewise. So moving more neural network, so it is generally designed for processing sequence data, which already we have seen. This is also more motivated from the biological example, and it is general form of neural network. So let's say this is your RNN. Okay, that these are the, let's say neurons are there. So this is your RNN having some input, sequence input, and then you are getting a fine output over here. How this input is a process in RNN, that we want to see at this point in terms of discussing equations. Now moving further to see the details of the equations that are there in RNN. So input will be sequence of vector that already we have seen. X1 to Xt are the different sequences. Okay, so this X1 will handle some size of data, then X2 size of another data, likewise. IT. Okay. And the goal of RNN is to minimize the loss. So it will, how it is minimizing loss, and what are the other problem that we will see. Loss will be get calculated. This is the output which was generated, and this is the target. So definitely this output must be more closer to the target. This is the target, and towards to this target, the output we want. If there is a much gap in the output, so then this loss will be get back propagated in the RNN, so that it will going to adjust all the weights and try to minimize this particular loss. So to calculate, it is having some expected output and the output which it has derived. Right? So with these notations, we'll move further so that we can see the equations. Again, coming to the same point, xt, which is the input, The hidden state will be changed by the neuron, which is HT, and the output will be O of T. The equations of RNN that can be represented with respect to a particular input X of T is like this. It has some input Uij, which is connected to input J to RNN neuron I. Okay, so this is input J here and RNN neuron I. In between that, there is a some weight. Wij, so internal weight Wij with respect to here. Okay, and there will be a bias. Then output weight Bij connecting neuron J to output neuron I. From here to here, whatever the you will going to have some weight, and then you will get a last equation, that is H of T, which is the hidden state, and O of T, which will be the output produced by the neurons. Fine. So H of T is like this: tan H U into X of T. This is the input weight and this is the input value vector, plus this is the weight with respect to the neurons and the hidden state, which is the previous hidden state, plus bias. So now this will be the change in the state H of T, and then with you can calculate O of T. So for calculating O of T, it requires the output vector, output weight vector V into H of T plus C. C is the bias at that particular point. So with this, we get a two equations. They are very easy. Moreover, we want probability as our output. Okay, whatever we get, we want that in terms of probability. That means, let's say I get a probability 0.90. That means my output is nearer to the whatever is expected. 90% is correct. Okay, 90% nearer expected or desired output. So that can be done by using a softmax function. So you can apply softmax function after this particular output so that you can represent this output in the form of product, where you can see how near that particular output is. Fine. So moving further with this equation, now you can able to visualize everything with this particular slide. So this is your input. This is your input weight. This is H of T, which will be get changed when H of T minus 1 operated on weight and bias, and then this is a V of C, weight output and the bias to get the O of T. So this is the way the equations are RNN. Now moving further, the problem in the RNN. So now this is where just you try to understand there is a change in the color. That change in the color is indicated the loss of information. That particular information will be not available in the successive processing. So see here, the question is what time is it question mark. We want to predict what time is it. So this is the input given. To have this particular process, okay, this entire sentence is broken into small word including question mark. So what is get processed here, then that same is get passed on over here. So with respect to time, so now you can see here, whatever the output that is generated here, half of the output is passed on at this point. Similarly, likewise. So at this particular question mark, if I want to give the answer, because at question mark, this entire sentence is finished. There is nothing in input. Yes. At this point, to take a decision, what time is it? So what information about what and information about time is totally missing here. See here, it is nothing. Due to that, here we will not going to get the answer for this particular question. So here we are able to see the information is not available at a particular point when we want to make a decision. Only previous information available, which is not that much important. So with this, we will move further. This is a simple pseudo code for RNN, which is with respect to the olden libraries of Python. But nowadays we are library like Keras and TensorFlow. So in that case, we don't have to write down this much. Only writing an RNN simple RNN. Just you write it, so your work will be done. Just you have to pass the parameter. But still, we want to see this particular code. Fine. What we are doing, we are calling RNN method over here, which will be stored with this variable. Then we are creating a one object for feed forward neural network because it is a feed forward moving from left to right, so that all the data from into another. Then there will be hidden state. So initially all the hidden state will be 0, 0, 0. Then what we are doing, there is a particular input which already we have. From that input, word by word, okay, word by word, we want to process. So how we are processing? Some output vector and there is a hidden state vector. In output vector and hidden state vector, here we are calling the function called as RNN. In the RNN, we are giving the input word and the previous hidden state. Okay, so word, previous hidden state, it processing, keeps on processing, and those all informations are stored here and here. Once all the input word are processed by using this RNN, then what we have to do? We have to do the prediction. So for prediction, we have to apply feed forward network. Feed forward way, it will going to process this output, okay, and then it will going to predict. This is the this is the code from the scratch, but with the Keras and TensorFlow implementation, we are having line code for that. Now there is a certain problem with respect to RNN, so that we can visualize here when we do the training of RNN. So what we do the training. How the training can be takes place? So training will be in the three major steps. First step is forward pass and make the prediction. Okay, so in the first step, the entire data will be get processed by the RNN in the form of feed forward network from left to right. Okay, so at that time when it is happen for to do the predictions. Okay, so this problem comes in picture. The problem is short-term memory. So already we have discussed that RNN just know previous, only previous instance it is knowing, but previous to previous it is not knowing. So that is the problem of short-term memory. Okay, so that problem comes when we are doing the training with respect to forward pass. Then in the second step, what happens? Some prediction has been done. Okay, so what we do, that prediction we compare with the ground truth. Okay, whatever the prediction that has been done will be compared with the ground truth, and loss function is get computed. Loss function is get computed as an output which will be an error. So that error will going to tell how poorly the network is. Okay, that error will help to estimate the model. We say that the model is good. If error is more, we say that the model is not performing well. So what we have to do, this particular loss, we need to minimize. So for doing that minimization, the third step is get applied. So where we can take the use of back propagation. Okay, so we back propagate all that losses, okay, the network from right to left. Okay, so in the first step, the network will moving from left to right, and in the third step, the processing will from right to left. And at that time, it is that is back the errors are back propagated, which will be calculated in the form of gradient. Some gradient is get calculated for each and every node in the network. At that time, it is of vanishing gradient. Vanishing gradient problem says that whatever the losses that we are percolating from right end to the left end, yes, right end to the left end, those all losses are not reaching to the starting layer of that particular neurons. Somewhere up to middle, the processing will be okay, and there that particular loss is all negligible. It is nearer to the zero. Okay, it is very. So with that 0.01 or 0.12, if that is getting multiplied with the neurons, so there will be no much change. So that is the problem of vanishing gradient. So whenever RNN, if we are applying, so it is we are facing the problem of short-term memory, and we are facing the problem of vanishing gradient. So these two problems we have to solve. Okay, so to solve this particular problem, we are having the concept called as long short-term memory. Now here I can show you the figure how that feed forward neural network, just a glance you can have. So from left to right, everything will be moved. So this is the left, the input is x1 will be some input, the hidden state will be changed. This particular input will be given to the next neuron. and then some output is get predicted. C1 is generated. The C1 is what? This is the loss. Okay, this is the loss. So this way it is a feed forward network. Similarly, we are having a backward or feedback network, which is like this. Whatever the losses which will be generated at, those will be get percolated from last end to the first end. Okay, likewise. So here it is taking the help of some chaining rule. This might be discussed by the Diwan sir in the previous class. Going in the detail of this. So this chain rule is helping towards to calculate these losses from this end to this end. This is the same with respect to back propagation through time. This is one of the important concept, but I in detail with that because we want to cover the LSTM because which is the main important topic of this particular session. So in back propagation, what exactly? The step will work in opposite direction to forward propagation. We are moving from right to left. All the losses are calculated by taking the help of entropy formula. Okay, they are calculated over here, and all the summations we're going to get with respect to that interval, and all the losses are get calculated. These losses will feed forwarded to the neural network from right to left, and accordingly the neurons will going to adjust their weight, okay, towards to minimize the losses. The main concept of back propagation through time is to minimize the losses in the RNN. Different types of RNN, so that can be utilized. The RNN can be one-to-one, one-to-many, many-to-one, many-to-many, or many-to-many. So one-to-one means you are giving some input and you are getting some output. Only one, there is a one input, and one-to-many means you are giving one input and there are many output. The example for this is image captioning. You are giving an input and image, and it will going to give you different captions that are available on the image. So that's why one-to-many. To one, it is the best example is a sentiment analysis. In sentiment analysis, what we do, many input sentences we provide to the neural network. So here, this is your neural network. This, the middle layer is your neural network. This bottom layer is your input, and this top layer is your output. So only one sentiment, either positive, negative, neutral, sad, bad, something like that. Many to many inputs, many outputs. The example is machine translation that we have seen. The many sentences of one language will be processed by the artificial neural network. In this case, it will be deep neural network, and then translated sentences. Similarly, many to many can be utilized for speech recognition. The sequence of sound will be sent over here and words matching to that particular sound. So this way you can have any kind of a neural net, that is a RNN, with respect to the particular problem statement. So already we have seen this, the issues in RNN, that is a short-term memory gradient. So moving towards with this, now we require. So at this point, if any questions are there, so I'm going to take those questions. So already we are near to 4. Only till this point I am able to cover only. So any issues, any doubts are there, so you can ask. Okay, so moving further, the construction of LSTM. This is the particular RNN model which take care of the problem associated with RNN, that is memory and vanishing gradient. So in RNN we don't have memory. Okay, if we introduce the memory, so we can have the good RNN where in that memory we can have lots of data available, and as and when it is going to get supplied. So in RNN, so if you remove this particular portion, so this entire thing will be RNN. So we are adding the memory over here and some neural network and some function. This is sigmoid function is get added, and then point function and some point addition function is added over here. And here, whatever the data which you want to, whatever the information which you want to store, that will be made available here in the memory. And something which you don't want to remember, which will get forgotten. Right? Is get added in such a way that the form of forget gate. So forget gate will forget what is not important at a particular instance, otherwise it will keep in the memory. So now this is with respect to this point, that multiplication and addition. So that very simple over here. You are having a same size vector. If we'll do multiplication, addition, so they are get added and the result is get generated like this. Point by point multiplication, the size of input vector will be same. They are getting multiplied. It will get generate the output. So see here, multiplication and addition. Due to that, the values get increased. This value we need to squash it. We need to limit in between 0 and 1. So for that particular purpose, we can use either tanh or sigmoid function. It is totally depend upon what exactly we want to do. Now, so as LSTM we are discussing, so it is having the concept of gate mechanism. Gate mechanism says that allow or disallow. This is a very simple which you can understand. Suppose these are the signal pointed, 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 and now suppose these are the chances of allowing this particular signal. 1.0 complete signal will allow, 0.5 half of the signal, 0.0 is allowed. So this is the gating mechanism. With that, if we'll multiply with points in multiplication, so we get a result like this. So with this, complete signal is passed, half of the signal is passed, and no signal is passed. This is exactly the gating mechanism applicable in LSTM. The symbol which we have seen here, this is called as a sigmoid over here. This is already known to you. What it does, it is called as a logistic squashing function. The job of that function is limit the result from 0 to fine. With that, we got one more gate is get introduced, which will be the output gate, and then one more gate is required, which is called as the input gate. So the job of this output gate is whatever is required that need to produce, otherwise do not produce, because it is a squashing function sigmoid. What it will do, it will attenuate the signal from 0 to 1. If means it will not produce the output, 1 means it will produce the output. And this is the input gate. Job of input gate is whatever is need to produce, which will be supplied here, otherwise do not supply. And the job of forget gate is just to forget what is not important. So with this, we get the structure of long short memory. So here we are getting so much is a memory here also here, because memory means what exactly we need to required, and here we are having the physical the memory which is in the form of gate. Okay, in the form of gate, where what is required, what is not required, that we can attenuate. So in this way, the RNN is get modified towards to have a long short memory. And now in this case, this will going to help you to solve the problem of that vanishing gradient and solve the problem of short term memory. If you like that, if you allow me to continue, so I'll continue, otherwise I'll stop because already the time is over. Yes. So with this particular, we want to have one example get simulated, and then you can get an understanding that how that the real is the problem of RNN is get solved by using LSTM. Okay, so I'm getting your response. So we will simulate that same example of children's book. Okay, in the children's book, we were getting the problem that the sentence is continually, or it is generating a wrong signal, wrong sentences, or sometime it is generating the short sentences. Fine. So now we will simulate that same example, and we will see that LSTM is solving that problem very efficiently. Fine. So we will move the problem. Okay. So now take an example. So now this LSTM was trained on this sentence. Jane saw spot dot. Okay. So this was the input. On that input, this LSTM is already trained. Okay. And we got prediction. Okay. This is the latest prediction from this end. Right. Fine. Okay. So this was the old prediction which is available over here. And this prediction we got for this particular sentence. Fine. Now it is Dick. Okay. My input is Dick. So this is the latest input. This is the previous prediction. See. So this and this over here. Okay, new information is Dick. Was a Dick, Jane, and Spot. Okay, fine. So this prediction and this data is get concatenated all these neural networks. Okay, they will do their job effectively. So the job of this particular neural network, whatever we see, they will just do the best prediction. Okay, best prediction. So see how what happens. This plus will go here. The job of this, it will give you the best possibility of the predictions. What can be that particular word. Okay. So now with this particular neural network, it is giving you the positive prediction for saw, prediction for Dick, because this neural network knows Dick, and from this and from this and this, it is knowing that Dick cannot be the next word. Okay, so that's why this Dick here is in the different color. This is the positive prediction at this point. Fine. Now this prediction will go here. Fine. Now for the simplicity, let's say here after processing this and this, suppose don't have anything for input for simplicity. Then in next iteration we will see. Okay. So for simplicity, nothing for the prediction, nothing to input over here. So saw and Dick will go as it is here. Fine. The saw and Dick will be available here. Once again here, let's say we don't have anything to forget, don't have anything to remember. Fine. Don't have anything to forget, don't have anything to remember. Fine. So with this is a saw and Dick once again will go here. When the saw and Dick is here, see this arrow is available. This is saw information is also made available at this particular point. Later on, we will see what happens for this. So at this point, saw and Dick was filtered from here and it is filtered here also, and it is available at this particular point. Now there is a squashing function. The squashing is this. Which one is this? -1 to 1. So it will squash this result here. And now let's say at this particular point, we don't have anything to, for simplicity, okay, don't have anything to produce. So now it will come over here, and the saw is the positive prediction. Here, saw is the positive prediction and saw is get predicted. Okay? Now this is the, let's say, first iteration. Now in the second iteration, you will get all idea clear. So after Dick, what the prediction has to be saw. So okay, we got a saw. Now moving for the next. So now the next prediction is a saw. So next word is a saw. So that was predicted correctly. Yes. But after saw, what we require? We require word. Yes. That cannot be a Dick, but that has to be someone else. That need to be get predicted by this LSTM. Right. So that we will going to do here. So saw is here. That is the input. And saw is the previous prediction. Saw will come here. Yes. Saw is here. So with respect to what can be the best possible prediction that has to be done by this neural network. So it is correctly doing Dick, Jane, and Spot. So this is the possibility has to be with respect to saw. So with this, it will. So here it was. Okay. So with respect to the saw and this particular possibility, saw can we go further. So once again, a Dick, Jane, and Spot will be made available at this particular point. Fine. Now, if we'll see in this example, this saw and Dick was the output. So this will be made available here. Yes. So saw and Dick is made available over here. So if we'll see, this saw will be forgotten and a Dick will be kept in the memory. So why saw will be get forgotten? So here it will get the information saw and saw. So saw will be input at this particular point, and saw is was the previous prediction. Okay, previous possibility. Saw cannot be the next word. Yes, saw cannot be the next word. So saw will be forgotten. Dick will be remembered at this particular point. So now Dick is available here, and now here we are getting some another possibility. Dick J, it is getting multiplied. But see over here, the Dick was at this particular point. This Dick here will going to have a negative negative uh, weight at this point. So this negative weight and this get cancelled. Okay, just for the simplicity I am saying. So this is in the dark black color, and this is not be the correct prediction. Jane and spot will get filter at this point and it will be made available. Moreover, Jane and spot will be fed here in the next iteration. Okay, now here saw and saw is the input. Yes, so this is available here. So with this saw, Jane and spot are the more appropriate word and they will get made available at this point. The best is the Jane spot. Now Dick is absolutely omitted at this particular point, which was not the case in RNN. Okay, in the RNN, Dick saw Dick can be possible, but here it is not possible. So in the LSTM solving the problem of RNN. Okay, so at this point I stop. If still you are having any question, I'm happy to answer. If any questions are there, you are welcome. So the question is, can we use LSTM for classification? So yes, you can use a LSTM for classification. Easily you can use. Here LSTM can be utilized for different way. It can be used for classification. It can be used as an encoder. It can be used for. So here also that same thing we are doing. Yeah, so there is a what is an advantage of RNN compared to CNN. So RNN is totally different. CNN is totally RNN. It is generally for data modeling. CNN is for feature extraction. So CNN generally get applicable on image data. Yes, RNN is most of the time get applicable on sequence values. Okay, they both are different, so you cannot compare them. But you should know that whenever you want to extract the feature, your first answer must be CNN. Whenever you want to process sequence data, your first answer must be RNN. So implementations are also there, but at this point it will going to take a time to discuss on the implementation. But I'm going to share those implementation that has been done. Yeah, you can apply one-hot encoding. Just you try to see what kind of raw data which you have. Okay, what kind of raw data which you have, you can apply it. There is no problem. Moreover, with respect to Keras and TensorFlow, you can apply some encoding technique on the particular data. Encoding technique on the particular data. RNN for sequence value, it can be used for sequence images. Yes, yes. RNN you can use for the data which is in sequence. In the starting, we have already discussed your data can be image which will be in the sequence. Data can be audio which will be in the sequence. Your data can be in sequence. Okay, so I thanks to everyone who how RNN is different from reinforced learning. Okay, so reinforced learning is a different concept. Different reinforced learning, it is associated like you have in the discuss supervised learning that I have told you in supervised and unsupervised, and there is another technique which is called as a reinforced learning. Okay, so there we are taking the we are reinforcing the learning on the particular data where it is this and this both are totally different terms. Here you cannot process the sequence kind of data in the uh, reinforced learning, and in RNN, the sequence data. Okay, so if any other questions are there, so I'll try to answer those questions, and then we're going to move towards the valedictory part. So we are collecting the feedback. Okay, I'll share the feedback. At this point, I did not receive the AICT, but we have prepared one feedback link similar to that. So we will take that, and the moment we will get the Atal feedback link, that also we're going to share with you. Okay. So I'll share that feedback link at this point. Request everyone to fill the feedback form. Feedback link is shared on the chat. So you can take a 5 to 10 minutes to fill the feedback, and then we'll start the valedictory function, and then immediately in 5-10 we'll wind up. Moreover, certain things I want to share with you. So I'll open the website of IIIT Nagpur. Okay, so there are certain things through which you can associate your student to IIIT Nagpur. In the IIIT Nagpur, we are having the opportunity of association to student in terms of, so IIIT offers internship, 2-month summer or winter internship, and 6-month summer or winter internship. Okay, so for this particular internship, the student has to directly send a CV to the respective faculties. It is already available on the website. These are the different faculties they are engaged or they are involved in the internship. Just what the student has to do, he has to send the mail to the respective faculty by seeing the domain. And then they will scrutinize that application, and they'll select the student for the internship. So here the purpose of internship, it is not only giving the certificate, but the purpose of internship is student can get benefited out of that. Moreover, they can have a kind of skill enhancement or kind of a publication. Okay. So I encourage you that your student, you inform to your student that such kind of internships are available.
Sir, excuse me, sir. Is arts and science students are eligible for applying this internship, sir?
Arts means
Yes, same here, sir. Science students, are they eligible?
Here the eligibility we have kept BTech, BE, MSc, CS and IT only.
MCA, sir?
MSc are eligible.
MCA we have not taken over yet. So we try to send it. We will see. We will take an approval from the institute for MCA as well.
Thank you, sir.
Sir, what is the procedure, sir? Only after applying CV? How they are going to shortlist? Yeah.
The student has to send this CV. Okay, and the respective faculty will contact that particular student, and he can have some interview, and based on that, the student can get selected.
Okay, sir. Okay.
Sir, only MSc Computer Science are allowed? Not
yes, ma'am.
MSc.
So as we are having only 2 branches, here EC is also welcome. So MSc Electronics is there.
Okay.
MSc Electronics.
Chemistry, physics is not there. Okay.
No, because we are means only two branches are there, and these two branches are CSC and EC. So we are focusing on that only.
Okay, sir. Okay. Thank you, sir.
So it is a good opportunity. Last year I have allowed 7 students across the India. So 2 students from Tejpur University, 3 to 4 students from that is from here itself, and some 2 to 3 students from Delhi, Mumbai also. So out of that I got publication also. So it is a good opportunity for the student who want to go for MS or some other higher studies. 6 months is also there, which is a full-fledged, like if your university allows, because in most of the university the project is 6 months, that kind of project can be done here, where the one supervisor will be from here and you can be the other supervisor at your institute. Okay, so I request everyone to fill that feedback. So it is not that much big, so you take the time. So now we can move towards the valedictory function. So in the valedictory function, now we are having with us the head of the Department of Electronics and Communication Engineering, Dr. Tapan Jain sir. So I Tapan Jain sir for this valedictory function. Moreover, we are having one more professor from Computer Science and Engineering from IIIT Nagpur, Dr. Taushib Diwan sir. I welcome Dr. Taushib Diwan sir.
Thank you, sir.
Yeah. So I request sir to encourage us and to share his view for this workshop, which was started from 30th November, and today is the last day of the workshop. So, sir.
Sir, am I audible, sir?
Yes, sir. Yes, sir.
So very good afternoon, one and all present here, and thank you, Jiten sir, to give the opportunity to interact all the professors of different part of the country. First, I congratulate Dr. Jiten Tembune and to conduct such a nice workshop on data sciences and analytics using Python. I'm happy to share this news. We have, now completed the 13th total 1 and 3 13 workshop Atal FDP. Apart from that, we have also completed the certification courses in this pandemic and webinar for the industry. So the congratulations once again, Jiten sir, and I'm also during this last slide of the Jiten sir, we are always welcome for collaborative research or interdisciplinary research. I'm also share one important information. The Jiten sir and his group has this year is wonderful contribution in terms of the publication. So this group has published the large number of SCI and Scopus journal paper and also got one served DST project. So congratulate all the group members and thank you, sir, to invite us. And also my just one information I want to convey that we are running the PhD program and I am the PhD coordinator of this institute. So if you have any query related to the PhD program, you please drop a message to me. We are happy to solve your queries and concerns related to PhD program. And near future, if you have any collaboration related to the IoT, data science, and wireless sensor network, you can contact to our one of the group members or any of the faculty member in IIIT in Nagpur. So say this word because it's I know this is a very hectic schedule because we have to take out the time for the lectures during the exam. So I know to complete the session. So this I end my note and thank you very much and all the best to all the participants. Thank you.
Thank you very much for your encouraging word, and thank you for sharing the things that we are doing at IIIT Nagpur. So I give thanks to the management of IIIT Nagpur. I give thanks to Dr. O.G. Kakade sir, the director of IIIT Nagpur, for encouraging to conduct such kind of workshop. I also thanks to the Dr. O.G. Kothari sir, Dean Academic IIIT Nagpur, for helping us and encouraging us that we can increase of IIIT Nagpur so that more and more collaboration we can have with the outside world. I also thanks to Shri Kailash Dhakle sir, Registrar of IIIT Nagpur, for helping all the kind of supports, administrative help, support. And I also thanks to my colleague. I also thanks to all the speakers from different industries. I also thank the speakers from VNIT, IIIT, and the industry and academia, that from their busy schedule they have given their time and they have given full sessions. Moreover, moreover, I also give thanks to all the participants, because without you, it is not possible to have such a workshop. So I also congratulate all the participants, and I also congratulate the team of this workshop that they are able to successfully finished or completed this workshop. So thanks to everyone. Be connected to IIIT Nagpur in any way, and will definitely help you to sort out your issues and to your any problems in terms of research, in terms of any kind of PhD work, in terms of any workshop, STTPs, or any other thing. So thanks to everyone. If anybody from the participants, they want to share your views, now the forum is open.
Hello, sir. This is Nikita.
Yes, ma'am. Yes,
sir,
ma'am.
it was a wonderful session for 5 days. Though I could not attend all the sessions because of my classes, but I felt it was very informative and up to date. Thank you, sir, for the wonderful opportunity. Sir, and one more request.
Thank you.
Today's link I did not get, sir. Attendance.
I have pasted on here itself on the chat box.
Okay, that's a workshop feedback, no, sir?
Before to that, at the start of the session, I'll once again paste it.
No, I think
you don't worry for
lost
that.
the connection that time. I am not able to get that.
I'll send you. Just now, I'll send you. Just feel. So thanks for your encouraging words.
Thank you, sir.
Good evening, sir. This is Dr. R. Gunavati.
Yes,
really, we enjoyed very much in this 5-day program, short-term course. We learned many things from you, and the organizing is a wonderful one. The time management, everything is we amazed. Thank you so much, sir.
Yeah, thanks for your wonderful words and encouraging words.
Sir, good evening. This is Dr. Moshmi from Bangalore, Christ. Sir, it was a wonderful experience, and all the speakers took very nice, beautiful examples, because nowadays there are so many content available online and so many MOOC courses are there, and we have gone through, many number of such workshops. But your workshop, the examples which were provided, and the slides as well, it was really nice, and the time, it was never completed in a hurry, so the spacing was really nice. So I appreciate, and I do look forward to collaborate with your esteemed organization. Thank you very much for the opportunity. Thank you all.
Thank you, ma'am. Thank you for such a
Hello,
wonderful.
Sir. This is Sushma from Bangalore, sir.
Yes, ma'am.
Sir, all sessions, frankly speaking, all sessions were very wonderful. I could not attend all sessions, but whichever I have attended, it was very, very informative, and I could able to view all the videos and PPTs. Thanks for sharing all the videos and PPTs. So the main special thing what I observed compared to all FDPs is so real-time examples were stressed, and the speaker has motivated the participants to do the calculations and ask the many questions there. So that was more highlighting thing. It is not like one way. Someone is telling something and the other part was like just going on. No, it was very interactive, and they could able to keep a track between the participant. It was very nice, wonderful, and I thank that you have given opportunity for internships. It will be helpful for our students also, sir, in future.
Yeah. Thank you, ma'am. Thank you.
Thank you, sir. Thank you so much.
Yes, ma'am.
Good evening, sir.
Yes, good evening, ma'am.
This is Dr. Vidyut from Pune, Srinagar
Yes.
Business School. Even though I was not from core computer background, I liked all these sessions, and most of the sessions I was attending. Specifically, I liked Kelkar sir's session like Google Colab, which I found very easy to implement. And we really got rich content from, I would say, the experts. Okay, so this is going to really help us even in our MBA course for BA Business Analytics Specialization, because this data science and machine learning, this course is almost there in all syllabus nowadays. Like it is included in almost all the syllabus. So it was very helpful personally as well as commonly also. Thank you very much. Thanks a lot.
Thank you. So any other participant want to share his views? So we are very fortunate that it's a wonderful audience.
Hello?
They are sharing their really valuable feedbacks. Yes, ma'am. Yes, ma'am.
Hello, sir. I'm Panimoli from BMS College of Engineering, Bangalore.
Yes, ma'am.
Like as the participant told, it was really a wonderful session. I attended a couple of sessions like in other courses too. But yours, really, every speaker, everything was really very awesome. And one beautiful thing I liked is the stress management part, what you added. I'm not sure it's part of the program, but like yours, it was an exceptional, which was really very good. We should thank you for that also, because I'm not seeing any technical workshop doing a part on stress management. And it was really very nice. So I just want to add that to your compliment. Okay, thank you so much. Sir.
Yeah. Thank you, ma'am. Thank you. Everyone for sharing your views, for attending the session, for appreciating the efforts of each and every member as an expert, and yourself also, because from your busy schedule you are also engaged in your university and your college regarding taking the examinations and taking the classes. On top of that, you manage to attend the session, and on moreover you recognize that yes, something good has happened. So for that, I really thanks to every one of you. So thank you for such a wonderful journey, 5-day journey we had, and thank you for your encouraging words. So at this point, I give thanks to everyone, and yeah. So I'm getting more and more thanks on the chat box. So thanks to all. Have a safe life.
Hello, sir.
Yes, ma'am. Yes, ma'am.
Sir, I have submitted the screenshot of the test and the score to.
Yes.
I have emailed the screenshot and the test score.
Okay, ma'am. Okay. So I'll revert back all the mails, whatever I received today. So you don't worry for all those things.
Okay, sir. Thank you.
Yeah, ma'am. Yeah.